Hello children, welcome back. The chapter that we are doing is Polynomials for Standard 10. This is part 2. So in the previous part, we learned about the linear polynomial, the quadratic polynomial, their graphs, etc. And now we are going to learn a new concept, that is a relationship between the zeros and the coefficient of a polynomial. Now let the polynomial be f of x is equal to ax squared plus bx plus c, and we learned about what are zeros. Zeros is the value which will satisfy the equation. So for a quadratic polynomial, you can have maximum of 2 zeros. So let alpha and beta be the zeros. Now we are going to learn the relationship between the zeros and the coefficient of the polynomial. So let alpha and beta be the zeros. The sum of the zeros alpha plus beta is equal to minus b by a. That is minus coefficient of the x term divided by the coefficient of x squared term. And product of zeros alpha beta is equal to c by a, that is the constant divided by the coefficient of x squared term. Now the same for a cubic polynomial, let the polynomial be ax cube plus bx squared plus cx plus d, where a not equal to 0. So cubic polynomial can have maximum of 3 zeros and minimum of 1 zero, that we have learned in the last video. Now let alpha, beta, gamma be the 3 zeros. So the sum of the zeros will be minus b by a, and product of zeros taken 2 at a time, that is alpha beta plus beta gamma plus gamma alpha, that will be c by a, and product of the zeros will be minus d by a. So this is their relationship. Now forming a polynomial when zeros are given, it's alpha and beta be the zeros. It's given alpha and beta are the zeros. Now we have to frame the equation. So the equation will be k into x squared minus sum of the zeros, that is alpha plus beta, into x plus alpha beta. So when you do the problem, you will understand it better. And for a cubic polynomial, the same way, k into x cube minus, again sum into x squared plus sum taken 2 at a time into x, then minus alpha beta. So alternatively it will start, this is minus, then plus, then minus. In quadratic you have just minus and then plus. So we'll do a problem and then you will understand it better. F of x is equal to x squared minus x minus 2. You have to find the zeros and verify the relationship between the zeros and the coefficient. To find the zeros, you have learned in 9th standard factorization. So we have to factorize and find the zeros. So x squared minus x minus 2, this can be written as x squared minus 2x plus x minus 2. So x into x minus 2 plus x minus 2. So this will be equal to, x minus 2 is common, we'll take it out, and then you are left with x in the first term plus, here nothing is there, only x minus 2 is there, we have taken it out, nothing is there, it is 1. So x plus 1. This is the factorization of this polynomial. Now to find the zeros, equate it to zeros. So x minus 2 equal to 0, you will get x is equal to 2, and x plus 1 equal to 0, you will get x is equal to minus 1. So the zeros are minus 1 and 2. Now we have to verify the relationship between the zeros and the coefficients. For that, Now we will find the sum. Now sum. Now we know the sum of the zeros will be equal to, from the equation, from the polynomial we can write sum is equal to minus b by a. Minus b by a. Here the equation is, sorry, x squared minus x minus 2. X squared minus x minus 2. So before we start, we will write down a, b, c, and then we'll do it. So a is equal to 1, b equal to minus 1, and c is equal to minus 2. Now sum. Sum is equal to minus b by a. So minus b minus 1 by 1 equal to 1. And product equal to c by a. Here c is minus 2 by a is 1. So it is minus 2. Now we will do this with the zeros. So sum is equal to alpha plus beta is equal to minus 1 plus 2, it equal to 1. And alpha beta is equal to minus 1 into 2 equal to minus 2. See, if you see the sum both here, this is 1 and here it's 1 and here it is minus 2 and here minus 2. So hence verified. We will do some more sums. Find the zeros of the polynomial f of x is equal to 4 root 3 x squared plus 5x minus 2 root 3. Verify the relationship. Now to find the zero, first we have to find the zeros. So this also you have learned last year. So 4 root 3 into 2 root 3. So 4 into 2, 8. 8 into 3, 24. Now 24 you can write it as 8 into 3. So 5x is 8 minus 3, you will get 5x. So we will write f of x equal to 4 root 3 x squared plus 8x minus 3x minus 2 root 3. So this we will again, we will take 4x out. So you will get root 3x plus 2. Now here we will take root 3 out. So in the first term it is 3x. So root 3 has been taken out. So you are left with 1 3. And then x minus root 3 has come out. So you are left with 2. So this will become plus. Because minus root 3 you have taken out. This will become plus 2. Now if you see root 3x plus 2 is common in both. So that will be taken out. And then 4x minus root 3. To find the 0, equate fx is equal to 0. So root 3x plus 2 equal to 0. From this we will get x is equal to minus 2 by root 3. Then 4x minus root 3 equal to 0. So x is equal to root 3 by 4. So these are the zeros. Now we have to do the verification. Now our equation is 4 root 3 x squared plus 5x minus 2 root 3. Then you have alpha is equal to minus 2 by root 3 and beta is equal to root 3 by 4. Now add a equal to 4 root 3, b equal to 5 and c equal to minus 2 root 3. Now sum is equal to sum of the zeros is minus b by a. So minus 5 by 4 root 3 and product equal to c by a, that is minus 2 root 3 divided by 4 root 3. Root 3 will get cancelled and it is minus 1 by 2. Now here alpha plus beta is equal to minus 2 by root 3 plus root 3 by 4. Taking the LCM, 4 root 3. So 4 minus 8 plus 4 root 3 divided by 4 is root 3. Root 3 into root 3 is 3. So you will get minus 5 by 4 root 3. Now alpha beta is equal to minus 2 by root 3 into root 3 by 4. Root 3 cancel is equal to minus 1 by 2. Hence verified. So please write it in this format. This looks neat also and it's very clear. On one side you have used the polynomial, you have used the coefficients and found the sum and product. In the other you have used the zeros, you have already found the zeros. With the zeros you simplify and show it as equal. We will do one more sum. Find the zeros and verify. The polynomial is x squared plus 1 by 6x minus 2. So we will convert this as, take the LCM. So it will become 6x squared plus x minus 12. So we will find the zeros using this polynomial 6x squared plus x minus 12. So this 12 into 6. So I can 72, I can write it as 9 into 8 because it is plus x. So plus 9 and minus 8. So I'll write this as 6x squared plus 9x minus 8x minus 12. 3x is common from the first two terms. So 3x is 2x plus 3 minus of 4 is common. So left with 2x plus 3. If you are not very thorough with these factorization, please go to my playlist, go to the 9th standard chapters, and in that polynomials I have done all these questions, similar questions. So you can practice it from that. Now it is 2x plus 3 into 3x minus 4. To find the 0, you have to equate f of x is equal to 0. So you will get 2x plus 3 equal to 0. So x is equal to minus 3 by 2. 3x minus 4 equal to 0. So x is equal to 4 by 3. Now verification. So the polynomial is 1 by 6 into 6x squared, 1 by 6 into 6x squared plus x minus 12, or even you can take the other one also, the what is given, x squared plus 1 by 6x minus 2, and then here alpha is equal to minus 3 by 2 and beta is equal to 4 by 3. So here a equal to 1, b equal to 1 by 6 and c equal to minus 2. So sum is equal to minus b by a. So minus 1 by 6 by 1 is minus 1 by 6. Product equal to c by a is minus 2 by 1 equal to minus 2. Here alpha plus beta is equal to minus 3 by 2 plus 4 by 3. So taking the LCM, minus 9 plus 8. So minus 1 by 6. Alpha beta equal to minus 3 by 2 into 4 by 3. So it is equal to 2, 4 and 2 is minus 2. So hence verified. Find a quadratic polynomial the sum and product of the zeros are root 2 and minus 3 by 2 respectively. Also find it 0. So here they have given the sum of the zeros. So given sum of zeros is equal to root 2, product of zeros equal to minus 3 by 2. Now you have to frame the polynomial. So the polynomial will be f of x is equal to k into x squared. Now our x squared minus sum of x plus product, k into x squared minus sum is root 2. So root 2 x plus minus 3 by 2. Or we can write this as 1 by 2 into 2x squared minus 2 root 2x minus 3, taking the LCM. Now we have to find the zeros. So we have to factorize to find 0. find 0, factorize 2x squared minus 2 root x minus 3. So here it is 2 into 3 equal to 6. Now here, root 2x, so here middle term is root 2. So we have to see how to write that now. 3, so we can write this as 3 root 2 into root 2. 2 can be written as root 2 into root 2. And 3 root 2 minus 3 into 2, 6. 2x squared here it is. When I take the LCM, it is, I have made a mistake here. Two root 2x. 2 root 2x. Yeah, now we'll get it. So 3 root 2 minus root 2 will be 2 root 2. So that is how you will select the terms. So we will write this as 2x squared plus root 2 minus 3 root 2 root 2x. 2x squared plus root 2x minus 3 root 2x minus 3. So here the first root 2 will be common in the first two terms. So we will take root 2x, we will take it out. So in the first term it is 2. So 2 can be written as root 2 into root 2. So one root 2 has come out. So it is root 2x plus 1. Similarly in the second, 3 is common. So we will take 3 out. Minus 3 we will take it out. So root 2x plus 1. So this will be root 2x plus 1 into root 2x minus 3. So to find the 0, f of x is equal to 0. So root 2x plus 1 equal to 0, from which you will get x is equal to minus 1 by root 2. And root 2x minus 3 equal to 0. So x is equal to 3 by root 2. So the two zeros are x is equal to minus 1 by 2 and 3 by root 2. If you want, you can verify and see. This is only for your understanding. Sum is equal to minus 1 by 2 plus 3 by root 2. So 2 root 2 LCM. So minus root 2 plus minus 1 by root 2, sorry, it is minus 1 by root 2, sorry. So it will be 2 by root 2 this can be written as root 2 into root 2 by root 2, it is root 2. Product minus 1 by 2 into 3 by root 2. So it is minus 3 by 2 root 2. We will rationalize this. So this will become minus 1 by, oh, I am making a lot of mixed. It is 1 by root 2. So directly it is minus 1 by root 2. Yeah. So it is minus 3 by 2. So read the question. You will. This is what was given. Sum is root 2 and product is minus 3 by 2.